libraries you synchronize to those?
Yeah. Okay, so let me summarize the question. It's about pinning and virtual threads. So one of the challenges, one of the restrictions in the virtual thread implementation as it was shipped in the first version of Loom is that if code running in virtual thread either acquires an intrinsic monitor, does a synchronized block, or it calls a native method, the scheduler is going to hold that virtual thread on the carrier thread until it either returns from the native method or until it releases the monitor. And that has the effect of using up some of the carrier threads from the fork join pool. So with that as background, the question is, how did the situation come about? Did it surprise us? What do we recommend that people do about it? So let me break the two restrictions down because they're separate cases. In the case of pinning a thread when there's a synchronized block active on the thread stack, that is an accidental limitation. It's an interaction between the virtual thread implementation and the locking implementation. We had a choice. We knew that that these two features would interact negatively. The decision to say, okay, if this happens, we can keep executing, we can maintain safety, but we have to hold on to the carrier thread for the duration, was a compromise / workaround. And the choice that we had was, do we accept this compromise workaround, or do we say, we're going to wait and not ship virtual threads until we can rewrite the intrinsic lock algorithms? And we chose to go out with a limitation, being clear that this is not a permanent limitation, and we will fix it sometime later. I think that was a good choice, but it does mean that some old code may not be an ideal match for virtual threads without doing some refactoring. Sometimes that refactoring is very easy to do. Sometimes it's not. The other limitation is when you call out into a native method. This is not something that we can do anything but pin in this situation, because we have no idea what that native method's going to do. It's a complete black box to us, and we can't analyze it, we can't restrict what it does, and so that's a restriction that's not going to go away, although that's not probably what you're running into. Probably what you're running into is synchronized blocks. So the simple workaround for this is refactor from intrinsic monitors to reentrant lock, explicit locks in the library, and that works. Or wait, continue to use platform threads now until the rewrite of the intrinsic locks is complete. That's in progress. We're working on it now. Obviously, it's a pretty critical facility, the JVM, so it's not something that's easy or quick, but it is something we're working on. But the underlying trade-off that it illustrates is, okay, virtual threads are really cool. Do we release them now when they're useful for, pick a number, 85% of the workloads, or do we wait until it's useful for 95% of the workloads? And we made the choice that, okay, this is not a terrible limitation. We're not compromising safety. There's a workaround, and a lot of people will benefit from virtual threads. So that's the decision we made.
One thing I may add is that people can just look for JFR events or look for the stack traces, and then tells them when it happens.
Yeah, that's a really good point. So what this gentleman has added is one of the things we did do is we, whenever we end up pinning a thread because of one of these reasons, we trigger a JFR event that says, I pinned this thread, this virtual thread on this carrier thread running this code for this reason. And so you get a source of feedback that, if you're trying to diagnose performance issues and you see these JFR events, like, oh, okay, that's what's happening. And it really depends on, not just on does your code do this or not, but how much does your code do it? If it happens 0.01% of the time, who cares? No big deal. If it happens 90% of the time, you're gonna find that you have contention for the thread pool. But every workload is different. We didn't want to guess about what will all the workloads do, and so we released it with the instrumentation and with the warning that here's a limitation, and we let people make their own choices. Heinz.
If I remember correctly, the JFR event happens
unpin.
Okay, Heinz has corrected me that the JFR event happens when
I think-
when the thread is unpinned. That's believable.
Right,
Yeah.
so if you have a deadlock, if it gets stuck permanently, then you'll never see the deadlock.
Yes, if you have a deadlock, then you won't see the event, but you will see, there is deadlock detection in the, that was added in Java 6. And so that if you have a deadlock between intrinsic monitors, you will see that in the thread dump.
Not from the virtual
Yeah.
threads. Other side. Yeah, you can find it.
Yeah. Yeah.
No, it works only with virtual thread. I mean,
Sorry?
the deadlock detection works well also with virtual thread, as far as I know.
You can find it. But
Okay.
it's not
Yeah,
for
the
business
problem
use.
is that with virtual thread you have a tons of virtual thread. It's harder to find in the log probably, but it works.
Yeah, you can find it.
Okay.
Alrighty, so more questions?
I may have a question related to patterns. The instance of pattern, it's probably based on my own ignorance, but based on the examples that you have shown, I suppose that it works at compile time, so you should be able to do this with generic types, and there is no runtime component for this. There's no need for reify generics.
So the question is, does pattern matching require generic reification, and does it work with generic types?
Yes.
And so what we do when you pattern match on a parameterized type is we infer the parameterization. So you don't have to actually give it the whole parameterization in the pattern, but we will infer that parameterization for you, because there really can only be effectively only one given the given what the switch target is, and at that point we know everything we're going to know about the types, and so if we could not determine the match with only with the information that we have statically plus the dynamic type of the of the receiver object, it's not going to it's not going to try. It's going to say I don't have enough information to answer that. Okay. Gentleman in the orange shirt there.
Yeah, I wanted to ask something different about pattern matching. I saw your presentation, it was awesome, and given the fact that it was like an iterative process, right, I was wondering how you folks dog-fooded the stuff. And I do know that the class file API makes like a huge use of that. I was wondering like what else were you guys actually using it on, and it turns out it's so good. It's so actually practical in real terms. And it's not like a theoretical exercise.
Yeah, so the question is, what kind of feedback did we have on our own coding that guided the pattern matching work? So, do you have an example you want to take?
Yes. She mentioned class file API.
Yeah.
So, like the class file API is definitely one of the most intense users, I would say, and even now, for example, for me now, I am working on extensions on pattern matching, and I needed to add a new attribute, for example, to carry some additional information, like for the code generation. And this facility guided me a lot, like instance of pattern matching, and like combined with sealed interfaces and these hierarchies. It made my life as a programmer now, like as a programmer of I was going to extend the class file API a little bit easier. So that was one of my recent approaches.
And in the class file API, that was something that we were working on for quite a while. And so we started writing all of that code before we had any pattern matching in the language. But we knew that that's where the language was going, and it had a significant effect on the API design. So if you look at the API design for the class file API, there are the representation of a class file as a stream of class file elements at various granularity was influenced not only by the desire to do functional transforms over class files, but also because we knew that as soon as we had pattern matching, that's how all of the class file API clients would work. And as the pattern matching came into the language bit by bit, we were able to refactor first to type patterns and then to richer patterns as we went. And we had a similar kind of feedback loop going on in the Java 8 days between the language work on Lambdas and the Streams API. And co-developing the Streams API with the language facility was a huge deal in terms of feeding back. Here's something I'd like to be able to represent. The current iteration of the language doesn't let me represent that. And then we would have to sort of debate amongst ourselves of, is this efficiency in the language, or are you just like brain locked on this one API idiom when there's a better API idiom that you could be using? And so ever since then, we've really tried to make sure that each language feature, there's at least something in progress that uses it, as a validation and as also idea generation.
So string templates, what's the plan?
So, all right, so the question is, what's the plan with string templates? We're figuring it out. So you could look at this as, a disaster, or you could look at this as the process working correctly, right? And so we developed the preview, or so the background is for anybody who hasn't read the Reddit flame wars. So we built the string template feature with the explicit intent that this was not merely about interpolation, but it was about being able to represent expressions as a mix of static text content and embedded expressions, and then have domain-specific processing that included validation, sanitizing, and conversion, of which interpolation is just the least interesting example. A lot of people really just want string interpolation, and they don't care about any of that security mumbo jumbo. And so the feature that we had was tried to strike a compromise point, and it ended up being a compromise point that satisfied no one. And so in the decision of, are we ready to finalize this or not, we kind of surprised ourselves saying, no, we don't like this as much as we thought we did. And the preview mechanism that we built, back, we probably started this in Java 11 timeframe.
Java 12, yes.
Yeah, it anticipated that, there's a period where you can still say no-go. And that gives us the flexibility to put out things, not that are half-baked, but that are candidates, but we're not sure about them. And so far, every other preview feature that we built has finalized with relatively either no or little change. Most features finalized after 2 rounds of preview. Some took an extra round to work through some changes. Some took a couple of extra rounds because they were waiting for another JEP to catch up. That just made more sense for 2 JEPs to exit preview at the same time. So this was the first time where we actually pulled the trigger and said, no, we're not satisfied with it. We have some new ideas, but those new ideas weren't well developed enough to say, okay, we're going to try a 3rd preview with the new ideas, but we have no confidence that they're right. We want to have more confidence that we're right, and so we withdraw it, and hopefully it comes back Java 24, Java 25, some other time.
So let me just ask you a bit more. So the new plan is just interpolation, or still find this honest?
Yeah. So the new direction that we're exploring is that the star of the show is templates, not processors, and that when you have a string template, it evaluates not to a string but to a template, and then you can process it by passing it to ordinary APIs that accept templates. And we originally didn't think that was possible for performance reasons, but we came up with some clever performance tricks that enable us to do what we need to do. Especially, one of the motivations for this, one of the background motivations for this is string format is great, but it's dog slow. And the reason it's dog slow is, in addition, not for the reason most people think. Most people think it's slow because of boxing. And the boxing only turns out to be about 10% of the slow. The other 90% of the slow turns out to be the fact that you have to parse the format string every time. And that is way, way more work than actually formatting the thing. And so what you want is a mechanism that allows you to do the parsing of the format string once, hold on to that meta information, and then apply it quickly the next time someone uses the same capture site to come up with a different parameterization of that. So anyway, so we think we can remove the processor abstraction, leaving the template abstraction in place. But unlike the answer I gave to the gentleman in the orange shirt, the thing we didn't do this time around is write enough libraries with it, and that's what bit us. So we hadn't validated it enough, and we discovered only through a late experiment that, no, this isn't fun to use. And it's not satisfying the Reddit crowd either, so nobody wins.
It was fun to use creating like shell scripts.
Yeah.
And then because there was like no delicious backside, then it was really fun. But yeah, for other things like databases, like it was like mainly
And for like also for generating, like just generating Java source code programmatically, where almost every source generator, builds things in layers. So you build up some methods, and then you stick the methods into your class, and you build up the class further. And string templates didn't compose very well. And that was what really put it over the edge for us, where we had a code generator application from the Panama project, and the way templates composed with other templates was not satisfying. And that was the last straw that kind of pushed us over the edge.
Thank you.
Gentleman here.
Thank you. So we are moving from Scala to Java, and for microservices, and want to use modern features like virtual threads, structured concurrency, and scope values. And the question is around structured concurrency is something, if you intend to do any major changes, I think you just hinted at no, but I would be interested to know. And any improvements in that area, any changes would be appreciated to know about.
Yeah, so the question is, you're in the context of migrating an application that's primarily Scala to be more Java. You've migrated to a more recent JDK. You want to take advantage of the features of the more recent JDK, including virtual threads, and you're asking, how stable is the structured concurrency API, right? That's your question. Okay, so funny you should mention this. Because the meeting I have with Victor and Alan tomorrow morning is about the structured concurrency APIs. So structured concurrency is a really cool thing. Now we didn't invent this. Most of the innovation in structured concurrency happened in the Python community. And there was a great paper by Martin Sundstricht about this. And at the same time, it started to infect other language communities. So the Kotlin guys were experimenting with it, the C++ guys were experimenting with it. And the thing that's attractive about structured concurrency for me personally is, okay, so you remember, like, in the distant past, I wrote a book on concurrency.
Did you?
The worst chapter of that book is chapter 7, Shutdown and Cancellation, which is a grab bag of tricks that don't work that well, of how do we get concurrent activities to stop. And it was sort of, yeah, this is kind of what we got. It's not great, but it's what we got. Structured concurrency makes all of those problems just go away. And the reason it makes those problems go away is it doesn't create the problem in the first place. The model of threads are these fire and forget things only works if you never want to be able to say, oh, wait a second, come back here, right? And if you fire off a bunch of threads, but you want to retain the ability to get them to stop what they're doing on a timely basis when it's time to shut down for maintenance or something like that, it makes your program so much more complicated. And so what structured concurrency says is you're doing it wrong. you need to structure your program differently so that when an activity spawns a sub-activity, it should wait for that to complete. It turns out it's really surprisingly not hard to restructure things that were done with asynchronous threads in this manner. And because this works all the way down, where you spawn a thread and maybe it spawns its own subthreads, but if everybody waits for their children, in the end, you have a predictable way of waiting for all your potentially infinitely many subtasks. So it's wonderful. And I urge everybody to go read the structured concurrency Jeff. It's a really powerful way to think about managing asynchronous activity while still getting predictability for cancellation and shutdown. Now, I haven't answered any of your question yet. That's just the background. So when we released virtual threads, we released a structured concurrency API. One of the reasons why structured concurrency is so hot right now is it requires threads to be cheap. And historically, threads were too expensive to take this approach seriously. But now threads are so cheap that it's practical to do this, which is great. The API that we built was a stab in the dark. We figured, according to the usual preview process that we do, we put out something that was a candidate. We were waiting for feedback. We actually haven't gotten a lot of feedback. I don't think a lot of people have tried it. And so we've been slow to evolve it because we haven't gotten enough actionable feedback. Again, like the Spring Templates example, more recently we've started using it internally more. And we've identified some things about it that we want to improve. And so it's likely to go through another round or two of improvement before it exits preview. We're not too worried about that because we don't think a lot of people are dependent on it now, and we'd rather get it right. So all of that said, if you wrote code using the current preview API, I can't imagine you'd have a hard time migrating it to whatever comes next, because the concepts are still there front and center. It's really more a matter of how you coordinate between forking off the subtasks and collecting their results. And that's where all the API complexity is. And that's what we're looking at improving.
And also with the interaction with scope values, we don't see...
So the question is, how does this interact with scope values? Scope values and structured concurrency were co-designed. So there's, they both depend on a common, basically shadow stack management mechanism that ensures that if you start a process, in a given scope, you have to finish it in that scope. Otherwise, when you return to your caller, it will recognize that the stack is out of line. And both structured concurrency and scope values use the same mechanism for keeping track of that. So regardless of how it's evolved, we will continue to recognize that constraint.
I saw in your presentation that you are intending to introduce value classes. To what extent is that correlated to other features in other languages like living on the stack, like structs in C++? Is that the same, or are you considering differentiating your offerings here?
Yeah, so the question is, I heard about this value types thing. That sounds cool. Is that like what I've seen in other languages like structs in C? And the answer is yes and no. The benefits, so why does C have structs? C has structs because C works very hard to avoid allocating memory when it can do things on the stack. Java is generally more willing to allocate memory, but also much more willing to optimize away allocation and replace objects with scalarization and things like that. So the motivations for value types are similar, that we have this rift between int and integer, and we have these boxing conversions between them, and this is both an impediment to programming. It's this sort of like adds friction to writing your code where you think, oh, I don't want to box that, right? And also it has a performance cost. And so the motto for value types in Java is codes like a class, works like an int. But that's a simplistic motto because there are many things that are special about int, like they fit in 32 bits, that are not true of an arbitrary object layout. And so, the goal of value types in Valhalla is to allow the programmer to give up unneeded degrees of freedom so that the runtime can optimize memory layout better. So if you don't need object identity, you can give up object identity, and that unconstrains the runtime with respect to how does it lay out objects in memory, how does it pass objects between methods on the stack. But there are limits to that, right? Because there are some operations that only work because they rely on atomic memory fetches and loads, and the size that you can load and fetch atomically varies from processor to processor. So there's a bunch of complication that I'm waving my hands past, but the motivation largely is twofold: flatter and denser memory layouts, and erasing the rift in the language between primitives and their box types. So you can think about it as user-definable primitives. You can think about it as faster objects. They're sort of two sides of the same coin. You'll be able to write new numeric types like complex or half float or fixed decimal that will behave memory-wise like int and long and float do today. People are constantly asking, when are we going to get unsigned int? When are we going to get complex? When are we going to get half float? And we like to point people to Guy Steele's paper called Growing a Language, which says you don't want to build these new types into the JVM. That's a losing game. You want to be able to express these new types in ordinary Java code. And in order to do that, you have to, and do it in a performant way, you have to be able to give up some degrees of freedom that numeric types tend to not use. Numeric types tend to not need identity. They tend to usually not need or want nullity. And the 64-bit numeric types in the JVM have actually already given up atomicity. If you read, if you read the language specification, if you have one thread, writing along, another thread reading that long, you're not actually guaranteed to get both halves of the long in sync with each other. And that is a trade-off. It's a very pragmatic trade-off that came from the time when most processors did not have efficient 64-bit atomic instructions. They do now, but they didn't in 1995. And we had a choice of either make some broken programs safer or make all programs that do numerics faster. And it's one of the few cases where Java chose unsafety to get more performance. Authors of value types will confront the same thing, not at the 64-bit boundary, but at higher boundaries. So, I'm not sure I answered your question, so if you want to add to it.
Yeah, you answered it. If you don't mind, just a very quick follow-up. You mentioned that this will open the door to potentially bypassing binaries in terms of memory management. Does that mean that you can actually simulate unions in Java now?
So, the question is, does this mean we can simulate unions in Java? You can write value types that manage their own bits, but that all has to be within the class. So you could write a class that represents a union of a float and a long or something like that, and manages the bits for it. I'm not sure why you would want to, but you could. But you're not going to get undiscriminated unions like structs in C, because the cardinal safety rule that the JVM gives you, which is enforced by the verifier, is that it is not possible to basically cast a pointer to an int or cast an int to a pointer. And so if you want to manage bits to interpret them maybe as an int, maybe as a float, fine. If you want to manage bits to interpret them maybe as an int, maybe as an object reference, no, that's not going to work. So you, and then you, and then you and the guy. Questions are stacking up now. The gentleman in blue. Yeah.
Okay.
You're first, and then lady behind you.
I'm interested in widgets.
Okay.
And, the widgets are meant as restructuring the objects or something that matter. I'm more interested if there's some thought for how to construct the object. Because for now, sometimes we have a little bit bigger objects and it's unwieldy to have 7, 8 parameters. What is there in the works for this kind of situations?
Yeah, so the question is, boy, I love these other features you're working on, but there's a feature you're not giving me that I'd really like, and I'm wondering if you're going to give it to me, which is
I'm not asking why no.
Yeah, no. And maybe you're thinking that by name invocation of constructors or something like that, or something like that. Right.
More general, I
Right.
think would be better.
So Java committed to invoking constructors and methods positionally. So you declare a constructor, it has 7 arguments, you just lay out the types, and then any invocation of that constructor has to have those 7 arguments. And if you have 1, 2, 3 arguments, this is all great. And if you have 23 arguments, well, some people will tell you you're doing it wrong. But even if you ignore those people, your code is hard to read and easy to make mistakes, especially when most of those arguments are hits. And you accidentally, reverse the position of 2, and you get to spend an afternoon debugging, and then you say, boy, I'm an idiot, right? We've all done this, right?
Yeah.
So the question really is, are we going to get something better? One thing that people do today, which is not great, is to generate builders using something like Lombok, or by hand, which is terrible. That's not so great. Another thing that people would like to have is to be able to specify invocation by name and be able to say, if this thing isn't provided, then here's the default value. Some other languages have this feature. This is, it's a surprisingly difficult feature to graft onto Java. And the reason for that is, one of the most complicated parts about Java is method overload selection. And right now, method overload selection is entirely based on positional arguments. If you added in overload selection based on names, and then what happens when you have a by name method that's overridden by a method that doesn't guarantee that its names are available or uses different names? Oh my God, what are we going to do, right? So it devolves into a mess pretty quickly, and it almost always, I think, will trap people into thinking certain changes are compatible that aren't. Because if you have a constructor that takes 24 arguments, and let's say 22 of them have default values, you're guaranteed to want a 25th someday, right? If you got to 24, you're going to get to 25. And you're probably going to be thinking, okay, it should be a compatible move to add a new argument with a default, but that's not how invocation works in the JVM. So it would need a whole different translation scheme for how do we invoke methods by name, which is to say, this is a much, much more invasive feature than you would think. Now that said, we haven't given up on the idea. We just don't like any of the solutions we have. So we're continuing to think about the problem because we know it's a big pain point for people.
Thanks. Yeah, I read almost all these things already, and I
Yeah.
thought maybe something unsaid still back, but
Well, so that, I mean, the thing that might give you some hope is we haven't given up on the idea.
yeah,
We don't like any of the solutions we've found so far. So we'll keep looking. We're certainly, we know that people want this. We know people are in pain because of this.
I also think that maybe with withers, some people will misuse them for this kind of thing, and this could.
That's absolutely true. That's absolutely true. There, it's a good example of like, when people are in pain, they will do whatever they have to get out of pain, right? And so they, if they see an unrelated feature that they can kind of distort in their head, like kind of looks like the thing they want, they're going to do horrible things. I don't know what to do about it. I don't want to say so nobody can have withers because withers are really, really useful. But I think there's going to be a lot of arguments in the community about that.
Yeah, the only problem is that the lack of one feature, make the other even worse. You do a lot of overload because you lack the possibility to define default values, yes.
But it comes back to the question the gentleman asked about virtual threads. Do we wait and not ship virtual threads until we fix the pinning issue? Or do we say, yeah, it's not perfect, but it's pretty good and you might like it? So, no right answer. You were next, man.
We were talking a lot about all these new features of Java and comparing it with other languages and advantages. But do you think that the language has features in the next 20 years? Or in the future?
Do I think that what in the next 20
The
years?
language will have features.
Will people
How
continue to
will
program in
people-
Java in 20 years from now? So the question is, you're investing all of this in improving the language. Where do you think people will be using Java in 20 years, right? That's kind of what you're asking. So I certainly hope that people aren't going to abandon Java. We're certainly continuing to evolve the language as if the things that we do today will be relevant in 20 years. Where the world goes, I don't know. Maybe the AI bots will do all the coding for us, and
Quantum computing.
and who knows? But certainly, for the last 30 years, people have made predictions of Java's imminent death, and they've been wrong every time so far. That's not to say that they will never be wrong, but we continue on the assumption that Java is still relevant. There's still, trillions of lines of Java code out there in the world. And people writing more, and people coming to Java conferences and asking us questions about when am I going to get this feature. So at least somebody's still using it.
Good question to wrap up.
So actually, this gentleman was next here.
Basically, I'm going to phrase this the way you asked at the beginning. How come you didn't do something?
Yep.
So, since Java has been one of the best languages in terms of concurrency and parallelism, got it right from the, 20 years ago or so, how come you didn't go towards building a distributed JVM that would actually implement a shared memory model over, a cluster of workstation? That's the first part. And the second is, are you, since we have this LLM revolution and everything, what are you going to do about it, and what kind of support for GPUs and the rest are you going to bring into Java, if possible?
Okay, so
If you have anything.
that's two very different questions. I will try to answer both of them. So the first was, why was there never a distributed JVM? And the second is, how is the AI revolution going to change Java, basically, right? Those are your questions. Okay, so the first one, there actually was a tremendous amount of work in the mid-90s about, there was the Genie, system at Sun. Sun invested a lot of money in that, and it turned out nobody wanted it. And so, at some point, we looked at how people are using this stuff, and we said, that's not the direction the world's going. And in fact, there were similar efforts going on in other communities, like the DOE initiative, Distributed Objects Everywhere. There was still the remnants of the Corba revolution happening at the time. And there was a dawning realization basically across the industry that this wasn't living up to the promises. And so investment in that stopped, and we invested in other areas, in things like better compilation, better garbage collection, which turned out to be, pretty relevant. So to your second question, which is, what about AI? So the way we think about this is, you don't want us to try to build, linear algebra libraries, AI model training libraries. That's not where our expertise is, and you wouldn't want the libraries we would develop there. What we do want is to make sure that Java remains relevant to all the workloads that anybody wants to throw at it. And over time, the workloads change, and that means we have to adjust our compilation strategy, and things like Valhalla, which is about improving memory layout, is very relevant to AI, right? Because, having a lot of machine learning models are trained with half floats because you don't need the precision of a full float. You want to be able to get twice as many nodes in the same amount of memory, and we want to be able to lay those big arrays of half floats out compactly and densely in memory. And so things like Valhalla and Panama are big parts of the AI story, even though they have nothing to do with AI. They're about enabling the VM to be a good substrate for doing machine learning work. There's also an initiative going on under Project Babylon, which is a newer project that is specifically about, so Project Babylon is about taking code that was written in Java and transforming it to run on other systems. So for example, like Link from C# is an example of that kind of transform, where you take a C# program that runs on collections of objects and gets translated into a SQL query. You can do the same thing with GPU kernels or vector instructions. And so Project Babylon is about generalized program transformation. There's a sub-project within it about GPU kernel transformation, so that you can write algorithms in Java and have them be translated into something that can run on a GPU. And if there's no GPU on your system, it will simulate it on the CPU. And so there's a lot going on there. Again, that's not about AI tools, but it's about allowing you to run these kind of workloads efficiently on JVM. Did someone say we're out of time? I think so.
Yes.
I think we're out of time. That's amazing. We filled the time again. Thank you very much, everybody.